u sine theta, all right, theta g divided by t. I have space problem here. Minus, because this time is minus sign, okay? I should have minus, of course, we're not comment, minus g, okay? Yes, minus g multiplied by, you know our t is this. That gives us u sine theta divided by g raised to power 2. So I'm left with u sine theta squared, this times this, right, divided by t minus g into u squared sine squared theta, all right, divided by g squared, because since I open this bracket, everything in bracket must be squared, okay, all right, is that okay? Let's put bracket here. So finally, this should give us u sine square theta minus, sorry, over t minus one of g will cancel. Now there's something we have left out. If you observe closely, we have half here. There is half here, so the half must be here. Okay, must be, look at it, there is half here, so the half must also be here. So that half is going to be this over 2. This will be d over 2. I hope you get what I'm saying. There is half here, and the half was omitted, so I've put it here now inside the g. So finally, this will give us, you know, we have g squared here. One of g squared will cancel. I have one g here remaining, and this g is gone. So that gives us half into u squared sine squared, you know, divided by g. Okay, divided by g. Okay, if you look at it, I made an error. This should be g because of our t. This should be g. Sorry about that. This should be g. Okay, yes, this should be g, and this u square also can multiply u square. So if you look at it closely, you see that this is u square sine square theta, right, minus half u square sine square theta. These are the same terms. So it's as if you are subtracting from a whole number half of it. So you are going to have finally h equals to u square sine square theta divided by g. So this gives us, what I'm now highlighting gives us the formula for the maximum height reached by the object. Okay? Is that okay? So the last thing is the time of flight. We have talked about time of flight. We have talked about height. The last one should be, I'm trying to record, but hold on, we'll get it now. Yes, the range. Maximum, the last one is the range. You know, the range is the horizontal distance the object covered. And you go by saying, you know, range equals to time of flight times, you know, from what we know, velocity equals to distance and time. Velocity equals to, distance equals to velocity times time. Is that okay? Distance equals velocity times time. So we are looking at the horizontal distance. So this distance equals velocity times time. So range equals to time times the component of u along horizontal, which is u cos theta. And you know our time of flight is 2u sine theta over g multiplied by u cos theta. Okay, yeah, u cos theta, good. So that gives us 2u squared sine theta cos theta divided by g. Is that okay? So our range r equals to, now for mathematics, u squared sine theta cos theta is 2 sine theta. Okay? So what I'm trying to say is that r equals to 2 u squared sine theta cos theta divided by g. This gives me, let me bring the u square out so that you don't get confused. U square is out. This is 2 sine theta cos theta over g. Okay, let me bring the g here. Sorry, just a slight, sorry, my little stuff fell down. Now, just a slight thing. Let's bring our G here. Okay, if G is here, so the whole of everything I have in the bracket here, which is 2 sine theta cos theta, should be sine 2 theta. So therefore, I have R equals to U square over G divided by sine 2 theta. Now, you find out when object travel like this, when you project object at angle theta, the maximum horizontal distance which is called range is going to be maximum when this angle theta is 45 degrees. How do I know? Go to this equation. What do you have? U square over G. When theta is 45, this becomes sine 90